Okay, we're back, and here are two more examples that look kind of similar to the one we did last time, although you'll notice with the first example that I'm about to work, I put a 1/2 in front of our x minus 2 quantity squared term. So let's go ahead and see what that does, if anything. So I chose the values that I needed to choose, and I think maybe you can be sneaky about it. Maybe you've already seen a pattern, and maybe you'll see a pattern as we're going through. I will explicitly state that pattern, of course, as we go through the video. So let's plug in 0 for x. This gives me 1/2 times quantity 0 minus 2 squared plus 1 equals, this guy in here, 0 minus 2 is negative 2 squared is 4, so I'm going to say 1/2, oops, see that? Psychology. All right. 1/2 times 4, which came from this term that I squared, plus 1. Half of 4 is 2. 2 plus 1 is 3. Feel free to double check my computations, of course. All right, now I'm going to plug in 1 for the x value and see what we get here. 1 minus 2 is negative 1 squared is positive 1 plus 1. This gives me 1/2 plus 1, which is, of course, just 1/2. Plug in x equals 2 into the equation. That one's nice because 2 minus 2 is 0 squared times 1/2. That's just all 0. This comes out to 1. And I forgot to put my 1/2 on my table. Okay, let's plug in the 3. Y equals 1/2 times 3 minus 2 squared plus 1 equals 1/2 times 3 minus 2 is 1 squared is 1 plus 1, which again gives us 1/2 plus 1, which is 1.5. All right, and plug in the 4. Quantity 4 minus 2 squared. 4 minus 2 is 2 squared is 4, so this gives me 1/2 times 4 plus 1. Half of 4 is 2, and 2 plus 1 is 3, so I got a 3. And of course, I did that on purpose. I set up the table to reflect the symmetry that I was looking for. And again, you can see the vertex in the table right here. How do you know? Because the values are symmetric around the vertex. The y values are symmetric around the vertex. So let's go ahead and put those points down. X equals 0, y equals 3. 1, 2, 3. There we go, is our first point. Next one is 1, 1.5. 1, 1.5, that's about there. 2, 1, over 2, up 1, okay. 3, 1.5. 3, 1.5, all right. And 4, 3, it's about right there. And of course, if you identify the vertex, all you're doing is flipping that over the axis of symmetry if you'd like, and you can automatically get those other points. And then I'll connect these in a smooth curve. Something like that. Once again, we can see clearly here on the graph, there's the vertex. It's located at point 2, 1. The axis of symmetry goes right through the vertex. Let me just do a little o big S, axis of symmetry. How about that? Okay, so that's interesting. It appears that putting that 1/2 in there didn't change where my vertex shows up. Now, it did change something, but it didn't change where my vertex showed up. In fact, what this factor in front of the quantity x minus or plus something squared term does is it changes how open or closed this graph is, okay? So if you got a fraction, a really small thing right here, then it's going to become more open. If you have whole numbers, increasingly higher numbers up here, it's going to become more closed. And I would like you to do several of your own examples to verify that. Let's take a look now at this guy. Y equals negative 1/2, quantity x minus 2 squared times that, and then plus 1. It's exactly the same as this one, only I stuck that negative right there. And it does, of course, change something. Let's see how it changes. So here I go. You can fast forward again if you'd like. I'm about to do all these computations, starting with the 0. So negative 1/2, stick the 0 in here. Okay. 0 minus 2 squared is negative 2 squared, which is 4, so I get a negative 1/2 times positive 4 plus 1. Half of 4 is 2, but I got a negative. Okay, so negative 2 plus 1 is negative 1. That's what I stick right there. Now I plug in the 1. Negative 1/2 times 1 minus 2 squared plus 1. 1 minus 2 is negative 1 squared is positive 1, so I get negative 1/2 times 1 plus 1 just gives me a positive 1/2. So I'm going to put 1/2 right there. Okay. All right, next one. Plug in the 2. Negative 1/2 times 2 minus 2 squared plus 1. That's always nice when it equals this thing over here, the x value that you're plugging in, because you get a 0. 0 squared is 0 times anything is 0, so this just comes out as 1. Now let's plug in the 3. Negative 1/2 times 3 minus 2 quantity squared plus 1 equals 3 minus 2 is 1 squared is 1 times negative 1/2 is just negative 1/2 plus 1. And again, that gets me to a positive 1/2. Okay. And then we'll put in the x value of 4. Oh, I did it again. That's so amazing. I say 4 and then I write 4 immediately. There is a glitch in my neural network. Okay, here we go. Negative 1/2, we're going to stick in the 4 for x minus 2 squared plus 1. Okay. 4 minus 2 is 2 squared, which is 4, and negative 1/2 times 4 is negative 2 plus 1, which is negative 1. And I set up this table previously, again, around that vertex, and that's why you see the symmetry you do. So let me plug in the points. And you can see I scaled my graph a little bit so that I could show it more clearly what's going on here. The first point is 0, negative 1. 0 for the x, negative 1 for the y. Okay. 1, 1/2. 1, 1/2. There we go. 2, 1. 2, 1. 3, 1/2. It's here. And finally 4. Negative 1 is down here. Trying to line that up real nice. Connect that with a nice smooth curve. And it's something like that. And this time it looks like our happy face is actually a sad face. It's going down. And that's because of that negative factor in front of my quantity x minus or plus something squared. Okay. So once again, if you got a negative factor in front of a form that looks like this, then it's going to turn that guy down, or it's going to look like it's going down. This time, the vertex is still the same, but it shows here at the top of the curve. So it's either the bottom or the top when you're graphing quadratics. Vertex. The point for that is 2, 1. So I hope that through these examples so far, you have identified a general pattern about where that vertex shows up when you're looking at equations of this form. And let me just also point out again, here's the axis of symmetry. It's not actually part of the graph. It's not one of the y values per se. Only the vertex right there counts as a y value. All it is, once again, is if you take this side of the axis of symmetry and you flip it over the axis of symmetry, you get a reflection. Okay, kind of looks like I guess a mirror image, maybe you could say. So let me go on in the next videos, and I'm going to start getting a little bit more general with what I'm talking about. I'm going to generalize this form and talk about it, and then I'm also going to relate it to the standard form quadratic equation. So stay tuned for that.